They're thinking in the brain.
Welcome to our podcast on the adolescent brain. We are 4 students from the University of Limerick studying to become secondary school teachers. The podcast was recorded in the campus grounds of the university on the 5th of November 2014. My name is Emma and I will introduce you to the concept of adolescence along with brain structure. Mikey will then discuss development of the brain, Aoife will discuss hormones, and Barry will then conclude discussing neuromyths and the side effects of changes in the brain. The road shown here symbolises the journey to adulthood that each adolescent must go through in their life. But firstly I'm going to look at what is an adolescent. Sometimes stereotypically known as a teenage dirtbag, an adolescent is someone that goes through the transitional stage of physical and psychological human development that occurs from puberty to adulthood. An adolescent is someone aged 13 to 19, changing from a girl to a woman or a boy to a man. We're now going to look at brain imaging techniques. Brain imaging techniques have allowed for doctors to determine structure and activity ongoing in the brain through CT scans, PET scans, or fMRI scans. We are now going to look at the structure of the brain. The structure of the adolescent brain is divided into 3 main parts. The first part is the brain stem, which connects the brain to the spine, and its function is to control factors such as breathing and swallowing. The second part is the cerebellum, highlighted in blue, sometimes known as the little brain. It is essential for coordination of movement and balance, and is the part of the brain that retains information on how to walk, run, cycle, or swim. Finally, the third part of the brain is the cerebral cortex, which makes up 30% of the human brain. It is often referred to as grey matter and consists of 4 lobes. The occipital lobe, highlighted here in purple, is responsible for vision. The parietal lobe, highlighted orange, is responsible for reception and process of sensory information such as touch. The frontal lobe, highlighted in pink, is involved in problem solving, decision making and planning. And finally, the temporal lobe, highlighted in green, is responsible for memory, hearing, emotion and language. I'm now going to pass you over to Mikey, who will discuss brain development.
The prefrontal cortex is the part of the brain that develops or changes the most during adolescence. It's the area of the brain responsible for the complex processing of information, such as making judgments, controlling impulses and emotions, and setting goals. The nucleus is the structure in our brain that directs our behaviour when we're motivated to seek an reward. Unlike the prefrontal cortex, it's an area of the teenager's brain that is very well developed early on. Teenagers tend to favour activities that require relatively low effort yet produce high excitement. An example of this would be video games.
Oh, that one's meant to be awesome.
Completed it.
Only came out last week.
Completed it.
What about this?
Championship manager. Completed it, mate.
You can't complete it.
Yeah, I know, but I got so good at it that the FA offered me a role in the England setup.
Did they?
I took Woking from the conference to the Champions League in 6 seasons. Stuff like that doesn't go unnoticed, Neil.
Next we have grey and white matter. Grey matter is located in several areas of the brain. The primary function of grey matter is to carry sensory information that comes from grey matter cells and sensory organs. This information is then passed to the areas of the brain that process sensory information. Intelligence and skill are often attributed to this grey matter, largely because it covers so much of the brain. Unlike white matter, this type of grey matter is found in areas of the brain that involve muscle control. White matter makes up parts of the brain and spinal cord and facilitates communication between grey matter and the rest of the body. Now I'll hand you over to Aoife, who will talk to you about hormones.
It is widely known that the biological changes that the adolescents go through can lead to alteration in their behaviour. This is primarily down to their interchangeable hormone levels. The limbic system, located in the prefrontal cortex, is very prominent in adolescent lives as it regulates hormones, therefore controlling emotions and reward processing. As the prefrontal cortex is one of the last connections to develop in the adolescent brain, the limbic system can become hypersensitive to hormones, therefore leading to a common characteristic in teenagers of irrational behaviour.
On Wednesdays, we wear pink.
Hormones are also valuable in adolescence as they are viewed as agents of protection and adaptation as they alter the brain's function and capacity to learn. Dopamine is a particular hormone that is essential for the regulation of movement and emotional responses. However, it is renowned for its imbalance in adolescent brains. This is due to dopamine brain regulation in the prefrontal cortex, which is still developing through the adolescent years. This can explain how the high levels of dopamine in adolescents can lead them to gravitate towards more thrilling experiences as their emotions are not regulated. The adolescent becomes more focused on the instant attainment of positive rewards, therefore explaining the adolescent's main characteristic of increased impulsiveness. Susceptibility to addiction in adolescents is down to substances such as drugs and alcohol, releasing more dopamine, allowing them to attain more of a buzz. Imbalance in dopamine also explains another characteristic in adolescents of hyperrationality, as the adolescent becomes concerned with the here and now. Research has shown that as fibers develop in the prefrontal cortex, the desire for impulsive actions in adolescents is reduced and lead to more balanced dopamine levels. After learning about the importance of dopamine, let's take a look at Kevin and perhaps have a better understanding of why teenagers go through all these changes.
Kevin? Darling, he's losing the power of rational thought.
And the use of his arms.
He's become a teenager.
Kevin?
What? It's your birthday, Kevin.
Oh, I know!
Happy birthday, Kevin.
Okay, stop going on about it, will you?
Now we'll hand you over to Barry, who will cover neuromyths.
Neuromyths are misconceptions that are often repeated, making them hard to correct. People may be familiar with neuromyths such as believing that there is a left side and right side of the brain, that vaccines can cause autism, that alcohol kills brain cells, or one of the most popular ones, that we only use 10% of our brain. Side effects. The developing adolescent brain is affected by both healthy and unhealthy side effects associated with alcohol, sleep, and sport. The developing adolescent brain is also more susceptible to risk. Alcohol. Alcohol has many negative side effects on the teenage brain. These side effects include blurred vision, slurred speech, slowed reaction times, and impaired vision. Blackouts and memory lapses are also very common side effects of alcoholic influence on the adolescent brain. Sleep. Sleep deprivation can have negative effects on the adolescent brain. Teenagers who do not get enough sleep at night due to staying up later but having to get up early for school are more likely to have problems with irritability, depression, and impulsive behavior. Research also demonstrates that teenagers that are prone to staying up late had much poorer academic outcomes. This was more prominent in teenage boys. Sport. There are activities that teenagers can undertake that have positive side effects on their developing brains. Sport is one of these activities. Exercise affects the brain on multiple fronts. Sport increases heart rate and aids and provides a nourishing environment for the growth of brain cells. It also increases growth factors in the brain, making it easier for the brain to grow new neuronal connections. Risk. The adolescent brain is known to be riskier than that of an adult brain. While teenagers are developing all the time throughout adolescenthood, so is their brains. This is why it is more likely that teenagers will be involved in or do something riskier than that an adult would do. Some examples of this behavior would be drug abuse, drink driving, and risky sexual behavior. According to a study done by National Geographic, late adolescenthood is when the majority of this risky or behavior takes place. To conclude, adolescence represents a major stage of brain development and is a great opportunity for students to engage in both educational and social development. Thank you for listening to our podcast.